What's up guys, it's Salman Fiaz and today's video is on AQ A-Level Chemistry 2017 paper 3 section B multiple choice questions. Which compound has the highest boiling point? So anytime it says that, 9 times out of 10 I'm going to be looking for hydrogen bonds, right? So which one has hydrogen bonds? So the NOF atom bonded to a H atom. If I look at B, that definitely doesn't, because that's going to be something like, that's an aldehyde, so it's not that. Look at C, that's a ketone, so it's going to be like that. And if I look at D, that is an ester, so it's going to be like CH3, C double bond O, then O, CH3, something like that. So therefore the answer must be A, and it makes sense. If you look at A, this oxygen is bonded to this hydrogen because this carbon is bonded to the two hydrogens. And yeah, which is the correct order of melting points of these period 3 elements? So what's going on? Correct order of melting points, so smallest to highest, or yeah, weakest to highest melting points. So phosphorus is P4, sulfur is S8, chlorine is Cl2, argon is Ar. So it's gonna be B then, Ar, chlorine, phosphorus. Actually no, it's not. It's not going to be that, because that's saying phosphorus has a great boiling point and sulfur no. It's going to be sulfur then, because that's S8, that's greater than P4, P4 is greater than Cl2, Cl2 is greater than Ar, and that makes complete sense, so therefore the answer is C. Question 7, which is not a correct statement. Transition metals form colored ions and complexes. Even though I haven't really gone through it in class, I know that's true. I've gone through it by myself. They display variable oxidation states, that's also true. A ligand accepts a pair of electrons. No, it donates a pair of electrons. So therefore, C is the incorrect statement. Table shows possible conditions of products for the cracking of alkanes. Which row is correct? Thermal cracking, high pressure, high temperature. Yes, that's true. Mainly alkanes. No, for thermal cracking, it's mainly alkenes. So definitely not A. Look at B, thermal, high temperature, slight pressure. No, that's wrong. Catalytic, high temperature, slight pressure, mainly branched alkanes, aromatics. Perfect. But the answer is C. Alhamdulillah. Question 9. What is the concentration in multiply minus cube of hydrogen ions in a Dismus sample at 290 Kelvin? And I'm given Ka. So what I would do is I'd write Ka equals H plus. Now I know it's a weak monoprotic acid, and I'm only told the solution to this, so H plus squared divided by Ha. I want to find out concentration of hydrogen ions, so therefore concentration of hydrogen ions equals square root of Ka, 2.51 times by 10 to the power 8, times by 2.00 times by 10 to the power minus 3. And it'd be useful if I had my calculator with me. If it said diprotic acid, then you would times the concentration that you had by 2. Well, it's not, it says monoprotic acid, so square root of 2.51 times by 10 to the power minus 8 times by 2.0 times by 10 to the power minus 3. I get 7.09 times by 10 to the power minus 6, therefore the answer is B. Question 10 was a pH of solution of potassium hydroxide, 290 Kelvin. Now potassium hydroxide, KOH. So I only got one OH minus sign. Now I'm going to use KW equals H plus OH minus. I want to find out the pH, so I need to find out concentration of H plus, and it's just going to be 1.0 times by 10 to the power minus 14 divided by 0.46, and then I'm going to substitute that into pH is minus log 10 concentration H plus. So yeah, quite a lot of steps for just one mark, but these one markers on the multiple choice are definitely not easy. And then pH is minus log 10 of my answer. I get 13.66, and remember pH is always 2 decimal places, so yeah. Question 11. What is the mass in milligrams formed when this much of propene undergoes incomplete combustion? What's propene in this equation? That's propene. I want to find the mass of carbon formed. So this. So I can see it's a 2 to 3 mole ratio, so I'm going to times that by 3 firstly. So 3.0 times by 10 to the power minus 3 times by 3, I get 9.0 times by 10 to the power minus 3. I want to find out the mass. Moles is mass over mR. Mass is the moles times by the mR of carbon, which is 12. What does that give me? And I get 0.108. But what is that in? That's in grams. I want my answer in milligrams. How do I go from grams to milligrams? I times by 1,000. So it's going to be, my answer is going to be C then. Because if I times by 1,000, that will give me 108. 1.0 times by 10 to the power 2 is also 108. Question 12. Which compound gives this infrared spectrum? Go to my periodic table and go to the data sheet. I've got a peak here and I got a peak here. Now if I look at there, that's literally 3,000, so that's, if I look here though, that's 1750. In between that, so that's a C double bond O then. That's a carbonyl. So I know that my compound's got to have a carbonyl group. So it can't be A because that's a halogen alkane. It can't be B because that's just an alcohol. Can it be C? Yes, it can. Butanaldehyde. Butanoic acid, well, that'd be C double bond O, and then your OH. I don't have any of that. This 3000 is just for CH. So the answer would be C12C. Which pair of compounds does not form a racemic mixture when the compounds react? Now, it's not going to be does not form a racemic mixture. Okay. But the ones that don't form a racemic mixture are the unsymmetrical, the ones that don't form a racemic mixture, symmetrical aldehydes or symmetrical ketones. Now that's not symmetrical, because if it was, it'd be like that, right? Yeah. So that will form a racemic mixture. This B that will, C that also will, D that won't, because if you think about it, that is symmetrical. So D is your correct answer. Question 14, which step occurs by nucleophilic substitution? So CH3 is CH3, use chlorine to get that. Then I use sodium hydroxide to get that, so it's obviously going to be step B. Because you use sodium hydroxide, war maker, sodium hydroxide, potassium hydroxide. Yeah, it's going to be nucleophilic substitution. Which structure represents a stereoisomer of cisplatin, where cisplatin is an anti-cancer drug? It's just how well you know the structure of cisplatin, and then you also know that cisplatin, well, it's not going to be C or D. It's not got NH2, NH2. It's NH3, NH3, ClCl. But I want a stereoisomer, so therefore the answer is going to be B. B is a stereoisomer of cisplatin. Question 16. The diagram shows the Maxwell-Boltzmann distribution of molecular energies in a gas at two different temperatures. Which letter represents the most probable energy at the higher temperature. So at the higher temperature, so I can already cross off B and D because that's for the normal temperature. At the higher temperatures, this graph is talking about this curve. So, well, energy is always measured on the x-axis, so it's got to be C then. So you just use, there we go. Actually, no, if at the higher temperature, I haven't gone through Max or Boltzmann, I'd say a decent while, but high temperature doesn't. Yeah, high temperature, it goes down a bit. Okay. Yeah, you just have to memorize that. So the high temperature is actually this one. So it can't be A or C. So I'm left with B and D. Well, energy is on the x-axis, so therefore must be D for the molecule. Most probable energy of the molecules at the higher temperature. Question 17. Which type is the contact process in which the vanadium is oxidized? C. How well you know your equations. Question 18. The structure shows a section of polymer chain formed from the random polymerization of two different monomers. Which pair of monomers could produce this polymer? So if I zoom in here, I've got this and I've got that, right? So CH2 CHF, yes. CH2 CH CF3, yes. Therefore the answer must be A. Because remember, with the monomers, I'm just adding the double bond, right? So yeah, it's gonna be A. First one. Question 19. What is the minimum mass in milligrams of zinc needed to react with this much of HCl? So it gives us the equation, but first thing we'd have to do is work out the moles of HCl using concentration times volume. And I'm going to do 50 divided by 1000 times by 1.68, 0.084 moles. 84. But that's the moles of HCl. I can see it's a 1 to 2 molar ratio. So therefore, divide that by 2. I've got the moles of zinc, 0.042 moles of zinc. Then to find out minimum mass of zinc, moles is mass over mR. Mass is going to be the moles times by the mR of zinc, 65.4. But I get my answer as 2.7, I guess 5 grams. I want it in milligrams. To go from grams to milligrams, I need to times by 1000. So my final answer is going to be 2750. So C then, because that's 1, that's 2, yeah. So the answer would be C. An equilibrium mixture is prepared in a container of fixed volume. The temperature of this mixture is decreased. The mixture is allowed to reach new equilibrium, which is greater for the new equilibrium than for the original equilibrium. Temperatures decrease. Well, I know forward reaction is exothermic, negative, so the backward reaction is endothermic. I decrease the temperature. Well, then equilibrium is going to shift to the right hand side, the exothermic direction, to oppose the decrease in temperature, hence increasing the temperature. So I'm going to get more moles of this, right? The mole fraction of carbon monoxide, that's no. The partial pressure of chlorine, no. The total pressure of the mixture, no. The value of the equilibrium constant Kp, well, it must be that, but I'll show you guys why. Because Kp is your products over reactants. If I've got more products, so let's say originally I had 10 divided by 2. But then equilibrium shifted to the right hand side, I've got more COCH2, Cl2, so I've got 20 divided by 2. Which one's a bigger number? It's going to be this one, right? So that's what Kp is. Kp is going to be bigger then. Question 21. Which Curly arrow does not appear in the mechanism of this reaction? Propanone reacts with hydroxide ions from equilibrium mixture as shown. So I go from here and I go to here, and what I can notice is that this hydrogen has been removed and I've formed a double bond here. Okay, so that first one, that definitely does appear. B, yeah, B definitely doesn't. Why would you go from the C double bond O to the middle of the C bond. C, yeah, that would, because yeah, it bonds to that, and you form your H2O, and then this one, yeah, that's why the oxygen negatively charged. So therefore, the answer is B. The diagram shows a pH curve produced by adding a strong alkali to a weak acid. Which point in the curve represents a solution that can act as a buffer? So it's going to be B then. Because with A to B, but A definitely not. With C, well, I'm already here, and with D, I'm literally peaked off here. Therefore, the answer is got to be B, and that can act as a buffer. Question 23: which alcohol could not be produced by the reaction by the reduction of the aldehyde or ketone? So reduction of ketone to secondary alcohol, reduction of aldehyde to primary alcohol. So the kind of alcohol I'm looking for is a tertiary alcohol. And if I draw out B, 2-methylbutane, 2-ol, methane, ethane, propane, butane, I've got an OH group in the second carbon. I've got a methyl group in the second carbon. Look what we have here. 1, 2, 3. That's a tertiary alcohol, so that could not be produced. Don't be fooled, like many students, including myself, probably would have fell for pentan 3-ol. It's got to be tertiary alcohol. No, because if we draw that out, methane, ethane, propane, butane, pentane, it's just going to be a secondary alcohol, so that's perfectly fine. So the answer is 23B. Which compound does not show stereoisomerism? 1,2-dichloropropene, 1,2-dichloropropane, 1,3-dichloropropene, 1,3-dichloropropane. Now, obviously, these alkenes will show stereoisomerism. And I know they've got 1,2-dichloro, 1,3-dichloro. They're not going to be symmetrical. Definitely not, yeah. So they do show stereoisomerism. So now I'm looking for B and D. Which one does not have basically a chiral carbon? I've looked at B, 1,2-dichloropropane, methane, ethane, propane, 1 chloro on the first carbon, 1 chloro on the second carbon, and then I fill it in. Is that a chiral carbon? Yes, it is, because that's one methyl group, that's a H group, that's a Cl group, that's a CH2Cl group. So that will show stereoisomerism, and therefore the answer must be D. But if I draw out D, methane, ethane, propane, 1,3-dichloropropane, there you go. You can see got hydrogen, hydrogen, and then these two are also the same group, so definitely will not show stereoisomerism. Question 25: which compound can form a polymer without needing another reagent? Without needing another reagent, so it's gonna be basically definitely not gonna be what's it called? D, yeah. Definitely not A, because all A's got just 2 OH groups, so that can definitely not form polymer without needing another reagent. So I'm left with B and C, and B's got COOH, COOH, but it will need another reagent, whereas C, I've got COCl, and I've got the OH, so yeah, the answer will be C, can form polymer without needing another reagent. Question 26. A solution of lead 2 chloride is completely dissociated in this. In 100% meter cube solution, what is the concentration of chloride ions? So, first things first, find out the moles of lead 2 chloride. So, 1.08, 8.2. Then I've got the moles. Moles is concentration of volume. Concentration is the moles divided by the volume, which is 100, which is 0.10 already divided by 1,000. That will give me the concentration then. 1.08 divided by 278.2 divided by 0.100. 3.88 times by 10 to the power minus 4. Yeah, definitely can't be that. So let me double check that. So I've got 1.08 divided by 278.2. Moles is concentration of volume. Concentration is the moles divided by the volume. Yeah, now I've got my answer. If I just put it directly in the calculator like that, it will give me a wrong answer for some reason. That's why you've just got to take it step by step, because these calculators, I don't know what's wrong with them. 0.0388. So that's 3.88 times by 2 times by 10 to the power minus 2. So therefore the answer is C, right? No, because I can clearly see from the formula I've got 2 CLs. So then I need to times my answer by 2. And therefore the answer is going to be 7.76 times by 10 to the power minus 2. Therefore the answer is going to be 26D. Question 27. The rate equation between iodine and propanone is that the rate of reaction was measured, and this one is definitely a tricky one. I've gone through this before, I'm pretty sure, yeah. So it says the rate of reaction was measured for mixture of iodine, propanone, and sulfuric acid. And we can see sulfuric acid is not in the rate equation, so yeah. Then it says in the second mixture, the concentration of the sulfuric acid was different, but the concentration of iodine and propanone were unchanged. The new rate of reaction was a quarter of the original rate. What was the pH of the, excuse me, alhamdulillah, of the second mixture? So, rate of reaction was measured. pH was at pH that. In the second mixture, concentration of sulfuric acid was changed. It was different. The new rate of reaction was a quarter of the original rate. So I'm timesing by 1/4. Okay, so first thing I would do is find out the concentration of H plus ions. 10 to the power minus pH. 10 to the power minus 0.70. Whatever that is. Because I know that... Oh yeah, because I know that the concentration of iodine and propanone unchanged. I don't care about iodine, right? Propanone, that was unchanged, and that's in the rate equation. So that's basically being removed, right? K, well, that's just going to be K, right? So therefore, rate is equal to the concentration of H plus ions. So therefore, if the rate was a quarter of the original rate, what happens to the concentration of H plus ions? It's a quarter of the original. Times by 1/4, and then to find out the pH, or pH is minus log 10 concentration of H plus. So minus log 10 of my answer, and I get 1.30. 27B. Question 28. What's the mole fraction of carbon dioxide in the mixture? Mole fraction, so it's going to be the moles of carbon dioxide over the total number of moles, right? And first thing I'm going to need to use is PV equals nRT. I want to find out the number of moles, N equals PV divided by RT. Pressure is 100,000. Volume, well, it's 385, but I want it in meters cubed, so times by 10 to the power minus 6. Divided by R, which is 8.31. Times by the temperature, which is 25 degrees Celsius, but then I need to add 273 to find it in Kelvin. If I do that, 100, 1, 2, 3, times by 385 times by 10 to the power minus 6. 8.31 times by 25 plus 273. I get the number of moles. And then I know it's mixed with this much number of moles. So therefore the mole fraction of carbon dioxide is going to be my answer over 2.89 times by 10 to the power minus 2 plus that. And I get 0.35. 0.349, so yeah, 0.35. Because basically what happens is I use what I did just now, PV because I know T, N PV or RT. I got the moles of carbon dioxide. I want to find a mole fraction, so it's going to be the moles of carbon dioxide over the total number of moles, so over the moles of carbon dioxide plus the moles of argon. Question 29, how many peaks does this have? I can't go through this because I haven't gone through this yet. Question 30, a student is provided with this much of this. The student was asked to prepare an ammonia solution with a concentration of that. What volume should the student add? So first thing I do, 1 divided by 0.050. What's the concentration factor? Times it by 20, right? Because if I do 1 divided by 0.050, that's what happens. And if I do 5 times by 20, I get 100 centimeters cubed. But that doesn't mean I'm adding 100 centimeters cubed. And initially, I've got 5 centimeters cubed, so therefore I just need to add 95 centimeters cubed. Yeah, question 28A, question 30B. Question 31, which ion is most likely to be in the solution? The solution absorbs light with wavelengths corresponding to red, yellow, and green light. Which ion is most likely to be in the solution? D, even though I haven't gone through this, it's Cu2 plus aqueous, and that's the ion most likely to be in the solution. Question 32, a reaction is exothermic and has a negative entropy change. So let's convert this word into something that's feasible. I mean, something that I can visualize. So reactions exothermic, so negative delta H, and has a negative entropy change. Right, and what's Gibbs free energy change? Gibbs free energy change is delta H minus T delta S. And I know delta H is negative, delta S is negative. So what happens? Well, what's going to happen is because that's a negative here, the reaction is going to be feasible, but it's not going to be always feasible. It's going to be feasible below a certain temperature. The reaction is feasible below a certain temperature. Question 33. Phenol ethanol can be prepared by the reaction between ethanol chloride and benzene. In a preparation with excess of benzene, the mass of ethanol chloride was that. Percentage yield was that. What mass was phenol ethanol produced? So first things first, phenol ethanol. And now I want to find out, first things first, the moles of ethanol chloride. So the moles is going to be the mass in kilograms, 10 by 1,000. So that will go 57 divided by the MR, 78.5. 57 divided by 78.5. Then I've got 1 to 1 mole ratio. Therefore, to find out the mass of phenol ethanol, I'm going to do my moles times by 72 plus 5 plus 12 plus 16 plus 12 plus 3. And then that's my answer for the mass, but I know the percentage yield is that. What's percentage yield? Actual yield over theoretical yield. I want to find out the actual yield, right? So then I'm going to times it by 62 over 100. No, sorry, not that. So 5.7 times by 10 to the power minus 2 times by 1,000, 57. That's the mass of ethanol chloride. 57 divided by 78.5. I've got the moles of that. And then I've got the moles of phenol ethanol. Moles is mass of MR. Mass is going to be the moles times by, so my answer times by the MR of phenol ethanol. I've got 72, 12 times by 6 plus 5 plus 12 plus 16 plus 15. And then times by 62 over 100, and I get 54. Because the percentage yield was that, then I'm going to do my answer times by 62 over 100, and I get 54 grams. Question 34, what is the pressure at 298 Kelvin? I know, okay, 130 centimeters cubed of oxygen, 40 centimeters cubed of nitrogen, each at 298 Kelvin and 100 kilopascals were placed into an evacuated flask of volume of that. What is the pressure in the flask at 298 Kelvin? Okay, so I'm obviously going to be using PV because NRT. Okay, and I want to find out P, the pressure. So P equals NRT divided by V. And the moles the total volume for this, not for volume, 130 centimeters cubed. Alright, I can do moles as concentration of volume. No 0.085. Divided by the volume in when the volume is always measured in meters cubed, so I'm going to go from dm cubed to meters cubed. So I need to then divide by 1,000. And then the pressure that's in pascals divided by 1,000. Oh, it says so if I do moles concentration volume 130 divided by 1,000 times by 0.50, I get 0.065 as the number of moles. So then I do 0.065 times by 8.31 times by 298 divided by the volume 5 times by 10 to the power minus 4. Still don't get it. What is the pressure of the gas mixture in the flask at 298 Kelvin? This is probably the most challenging. It is the last question, so maybe that's why. Unless I'm doing something wrong, because everything's telling me to use PV because I'm not T. So what I think I actually need to do instead is find out the moles for each gas. So moles of the oxygen 130 divided by 1000 times by 0.50, 0.65. And then the moles of nitrogen, 40 divided by 1000 times by 0.50, 0.02. And then I find out individual pressures. Nope. So 0.065 times by 0.865 times by 8.31 times by 298 divided by the volume. Well, the volume's always supposed to be measured in meters cubed in ideal gas equation. So yeah, 0.50 times by 10 to the power minus 3. And then I get the pressure in pascals. Pressure is always measured in pascals. But when in kilopascals, then I divide by 1000. I get 321. If I do the same thing for nitrogen, yeah, this is not, I'm not getting the correct answer, am I? Unless I've done a conversion wrong. Okay, so what I need to do instead is, first things first, I need to find out the moles of O2. Like I said so many times, moles of O2, but I'm using the wrong volume. So the moles of O2 is going to be the concentration yeah. So it's going to be 170. Actually, no, I can't just directly work out the number of moles. That's the problem. Because it was placed into evacuated flask of volume this. Yeah, but I don't care about that. I want the pressure of the gas mixture, so the volume of the gases. Alright, so now I use N equals PV over RT. That's what I need to use. So N equals the pressure in pascals, 100 times by the volume, 170 times by 10 to the power minus 6. Divided by R, 8.31 times by the temperature, 298. Then yeah, I get a different number of moles. Perfect. And then I use PV equals nRT again to find out the pressure, or the number of moles. Number of moles times by 8.31 times by 298 divided by the volume, 5 times by 10 to the power minus 4. Yeah. Then I get 34,000, perfect, and that's in pascals, then divided by 1000. 34 kilopascals, perfect. Alright, okay, so I just approached the whole thing wrong. That's volume, and so is that volume. That's not concentration, which I assumed. So what I do then, P because in RT, N is PV divided by RT, using the total volume, 130 plus 40, Then once I've done that, N equals PV divided by RT. I've got the number of moles. Then I use P equals nRT divided by V. I've got the number of moles. I've got R. I've got T. I've got the volume, which is that. Perfect. I get the final answer, 34 kilopascals, and that is the end of section B.